Okay, so we'll have a few kind of example questions here that are very similar to what I'll ask on Tuesday's quiz, okay, as well as on the unit exam, which I am currently working on. And I think on your unit exam right now, I'm going back and forth on it, but I'm looking at 1, maybe 2 acceleration problems in the written response and a couple of simple ones in the multiple choice right now. So it's definitely something you're going to want to be able to do, but I think from yesterday it looked like we're getting a pretty good handle on it, okay, for that. So what I would like you guys to start with, okay, is question number 2, okay, about the water bomb. I actually changed that question, and I might change it back actually. I used to not give the acceleration in that question, so it was like that context trick one, right? Yeah, the one that we did yesterday was like, hey, anything that falls is supposed to be 9.81, and that's something you are going to have to remember, okay, that if something is falling, okay, it's accelerating due to gravity. You don't have to remember the number, because the number's on your formula sheet, okay, but you do have to remember that anytime there's gravity, okay, there's a specified acceleration for that. You can just look it up. I mean, we use 9.81 so much that it's going to be a number you just know off by heart before you know it. Okay. So let's try number 2 and number 3, okay, for right now, and then we'll go over those together and see how we do. All right, I'll make them a little bit bigger, but they are in the digital workbook, okay, and this is on page, page 10. Okay, so looking at number 2, okay, we're dropping something out of a window. If we're dropping something, what's our initial velocity? 0, yeah. Okay, so VI equals 0 meters per second. The other thing is that the acceleration is 9.81 meters per second squared down. Okay, and we're looking for the final velocity if it falls for 4.25 seconds. All right, so there's our givens. All right, so we've got A equals VF minus VI over T, and we are manipulating for VF. So we're going to multiply both sides by T. Do I even need to move VI in this question? Why don't I need to move it? It's 0. Adding or subtracting 0 makes no difference to anything mathematically, so I don't even need to do that part. I can just go T times A, and I'll have my final velocity because it started from nothing. Right, so that simply means then 4.25 times 9.81, which will give us our 41.7 meters per second. Down. Okay, because we should say that. It asks for the final velocity of the water bomb, and that is a vector quantity. So it should have a vector. All right. Okay, let's have a look at number 3 here. So for number 3, okay, a fighter jet whose acceleration is 11.1 meters per second squared accelerates from 22 meters per second to 35. How do I know which one's which?
It gets bigger as well.
Yeah, it gets bigger. Since it didn't mention anything about slowing down, I have to assume this acceleration was positive. Again, that's another context kind of thing that I just have to get from the question. Okay, 22 meters per second to 35 meters per second. Okay, and we are looking for the time on that one. Okay, how long does it take in seconds? So A equals VF minus VI over T. So we're going to multiply both sides by T, and then we're going to add VI to that. Okay, and that'll give us our formula. Whoop, sorry, we're looking for time. Forget what I said there. I went too far. Okay, we're just looking for time. So we're going to multiply both sides by time. We're going to divide both sides by 8. That's better. That's the formula we want to use. So we'll take our 35, which was our final, subtract our initial, which was 22, and divide that by the acceleration, which was 11.1, and that'll give us our 1.17 seconds. Doesn't take very long with an acceleration that large. Okay, how would you feel if you were subjected to that acceleration? What's that? Impatient? Yeah, for the person standing on your chest to get off of your chest. Okay, if you experienced that acceleration, you would feel over 1 G worth of force acting on you. Okay, so you'd be pressed into your seat fairly hard. All right, does that sort of make sense?
Does this need a positive or negative? Since
No,
it's-
because it's time.
Okay.
Yeah, and so, yeah, I mean, I could make these both positive, because they were all, or all three of these positive, because they're in the same direction, but time is scalar, so it's one of those things that does not require a vector on it.
Okay.
Yeah. Okay, that's a good question, though, because we make such a big deal out of vectors all the time. Okay, let's have a look at some specific ones here. So let's say specifically, I want to look at five, 6, let's say 5, 6, and 9 right now. Okay, now in 5 and 6, vectors are important. All right, we know the speedboat starts from rest and accelerates at 2.01 meters per second squared for 7 seconds. All right, so VI equals 0. The acceleration is positive 2.01 meters per second squared, and the time is 7 seconds. Okay, at the end of this time, the boat continues for an additional 6 seconds. So this is like only part 1 here. Okay, then there's a part 2. And in part 2, it continues for an additional 6 seconds. Okay, with an acceleration of positive 0.518 meters per second squared. All right. And then following this, the boat accelerates, so there's a part 3. Okay, the boat accelerates at negative 1.49 meters per second squared for 8 seconds. Okay, what is the velocity of the boat at time 21 seconds? So 7 and 13, and then so at the end of this, basically. All right, so we're looking for VF here. I don't have VI for part 3. I don't have VI for part 2, but can I find them? As long as I do part 1. Okay, the final velocity for part 1 will be the initial velocity for part 2. And similarly, part 2 for part 3. All right, so we need to find VF, okay, for part 1. So that's going to be manipulating the equation. So we will have VI plus T times A equals VF for part 1. Since VI is 0 for part 1, it's just T times A. All right, so we'll have 7 times 2.01, so 14.07. Okay, so VF is 14.07 meters per second. That's going to be positive because it was accelerating forwards. All right, so now I can use that here as my initial velocity. And I'll do exactly the same calculation. Okay, VI plus T times A will give me VF. So now I'm going to have 14.07 plus 0.518 times 6. All right, so that number plus 0.51 was 517, right? 518. Okay. 518 times 6. All right, so at the end of that, I'm going to be moving at 17.178 meters per second, also forward. All right, now I'm going to plug that in here, 17.178. And to calculate VF, okay, exactly the same formula. So the good news is we only had to manipulate the formula once. We were looking for the same thing on every single part of the trip. All right, so VF will be T times A plus VI. I don't know why I wrote it that way when I wrote it the other way every time, but in the end it doesn't matter. Okay, so for that one we will have our 17.718, okay, plus 8 times negative 1.49. Alright, so at the end of that, we're looking at I got 5.26. I probably rounded some numbers off when I actually made the key, but it should be 5.26 meters per second. And that's still positive. Alright, so kind of a tedious question. Okay. How did we do on number 22? Everybody good with 22? So we got about 10 minutes left here. Next week we're going to be starting work energy theorem, and I just put the date for your unit exam on the board. Okay. It will be on May 31st. Right, that is more than 2 weeks from today. We may be done before that, but that's kind of the safe bet date. That means we will have about 7 days to finish the last unit. It's lots, okay? Because that 1 year where we had an extra week for Christmas holiday, I counted 4 days, okay? So we can, I don't want to have to do that, but we can do it in 7 days, easy, and then get a couple of days for final exam review in class, okay? So we're looking pretty good right now. We shouldn't end up having to have a unit exam on the very last day of class and you don't get to see, don't get to go over it or anything like that. We should be fine, all right? On that note, it's gonna get kinda crazy, okay? You guys have been through one round of final exams in January already, but everything starts coming due right there at the kind of beginning of June, right? I will do my best to limit that. We don't hand in a lot of stuff in the last unit, okay? So that'll kind of help that out a bit, but obviously you'll have a unit exam in pretty short order if a unit only takes 7 days to teach. Okay? So just kind of try and manage your time, start thinking about maybe you don't, if you got a part-time job, maybe that's not the best time to be working a lot of hours, okay, all of that kind of stuff, just kind of plan ahead if you can. So we will have still in this unit 2 labs, okay, one on work and energy and one on energy conversions, right? We'll get those done pretty quickly, but reminder that you have a lab due next week as well. This is probably the most lab heavy unit, okay, just because labs are easy to do in physics, because they always work, because that's the awesomeness of physics. Okay? You guys know the saying, right? If it blows up, it's chemistry. If it's green, it's biology. If it works every time, it's physics. That's not actually how the saying goes, but that's how physics people say it goes. Right? So you got a few minutes here if you want to, take out your phones and maybe have a look over your acceleration labs, okay, that are due next week, and tweak a couple of things there. I'd say that's probably a good use of